So in last class, we have discussed about soft tree configuration in BGP. I have shared the volume 2 book as well with you, all right?
Mm-hmm.
So please download that book. So we have discussed about soft tree configuration, in which we have seen few commands like clear, IP, BGP, asterisk, right? Clear, IP, BGP, asterisk, soft. Clear, IP, BGP, asterisk, in, clear IP, BGP, asterisk, out, right?
Mm-hmm.
This is also known as hard reset, for both in and out direction.
Okay.
Soft reset for incoming updates, or you can say for in direction. And clear IP BGP star out is soft reset for out direction. Okay.
Mm-hmm.
Then we were talking about scalability issues with full mass iBGP, right?
Mm-hmm.
So as you remember, as we have discussed, BGP is using some techniques to prevent routing loops, right?
Mm.
For iBGP, rule is that neighbor or BGP router never advertise prefix received from an iBGP neighbor to the next iBGP neighbor, right?
Mm.
And for eBGP, prefix received from an eBGP neighbor or a router discard update message if its local AS number is present in the AS path prefix, right?
Mm.
For eBGP, the rule was very simple. A router discard an update message if its local AS number is present in the AS path list with the prefix, right?
Mm.
So we know that that's not an issue because in case of eBGP, and we want that a prefix, if AS number is present in the AS path list, it means that prefix has been advertised already in that particular AS, right? So this tool is very simple, no issue, no problem. We don't have any objection here because you know that, right? If your local AS is present in the AS path list, it means that prefix has been advertised in your AS, right?
Mm-hmm.
The problem is with the iBGP because the iBGP rule is no. So if we have an ISP here. And this ISP is having, like, for example, multiple routers. So it's all about design, okay, Heather? Sometimes we don't build neighborship, or we use like BGP free core. In case of BGP free core, we don't build neighborship of each and every router. If you are using like BGP free core, this is R1, this is R2, this is R3, this is R4, this is R5, this is R6, this is R7, and this is R8. Okay. So as we have discussed, like if you want BGP free core, you can build BGP neighborship between R1 and R8 only, right? You can skip the routers, right?
Yes.
Yeah. So R1 will advertise prefixes to R8 and R8 will advertise prefixes to R1. But for example, if an ISP requires full, like BGP must be running on all the routers, right? BGP must be running on all the
Routers.
Because maybe there is a topology like this. This can be a scenario, right? Like all the routers are connected to other ISPs as well. So if R1 will only build neighborship with R8, it will give prefixes to R8 and R8 will give to this AS, right? It will not be given to all of these ISPs. So what you require in this case? You said that we need neighborship between all the routers. So now if you'll configure iBGP here, because all the router belongs to the same AS, you will configure neighborship of R1 with R2, R1 with R3. Then you'll configure neighborship of R2 with R3, R3 with R5, R3 with R4, R2 with R5. You'll configure the BGP neighborship like this, right? But you remember the rule now. If R1 will receive a prefix from a neighbor, AS200, and this is AS100. So if R1 will receive this prefix, R1 is receiving this prefix from an iBGP neighbor. So R1 will advertise this prefix to R2 and R1 will advertise this prefix to R3, right? But R3 will not advertise this prefix to R4 or R5. Or R3 or R2 will never advertise this prefix to further neighbors because of this rule. The rule is that a BGP router never advertises a prefix received from an iBGP neighbor to a next iBGP neighbor. All right? That's why we come up with the idea of full mesh iBGP. We come up with the idea of full mesh iBGP. We have total 3 solutions here. I think first solution is full mesh iBGP. Second solution is Route Reflector, which is also known as RR. The third solution is config tracer. Okay. So we have total 3 things here to advertise the prefix in the BGP domain. First is full mesh iBGP. Second is Route Reflector, and third is config tracer, right? Now, if you talk about full mesh iBGP, so in case of full mesh iBGP, what we have done in our class, if you want full mesh iBGP here, you have to build neighborship of R1 with R2, R1 with R4, R1 with R6, R1 with R3, R1 with R5, R1 with R7, and R1 with R8, right? This is known as full mesh iBGP. Then Then you will neighborship of R3 with R2, R1, R4, R5, R6, R7, and R8. Yes or no?
Yes.
So if you have total 8 routers, now each router will have this number of BGP sessions. If you have 8 routers, then each router will have 7 BGP,
Sessions.
right?
Okay.
Then total number of
Yeah,
sessions.
excluding itself, but yeah, all the neighbors.
So 8 minus 1. 8 into 7 is 56 BGP sessions, right?
Mm-hmm.
If we talk about like each host, each router. So if we talk about full mesh iBGP, requires BGP sessions between to configure full mesh iBGP. You have to configure router to build BGP sessions with every other router present in the place, right?
Mm-hmm.
Is going to increase the total number of BGP sessions in an AS, and as a result, number of the updates and the size of BGP and routing table will also be, right.
Increased.
If you want to configure full mesh iBGP, you have to configure a router to build BGP session with every other router present in the AS. It is going to increase the total number of BGP sessions inside an AS, and as a result, number of BGP updates and size of BGP and routing table will also be increased, right?
Mm-hmm.
Number of routers will increase inside an AS. The number of BGP adjacency will also be increased, right?
Mm-hmm.
For example, if you have 100 routers inside an AS, then 100, you can say each router will have an minus one number of adjacencies, right?
Mm.
If you have 100 router, then each router will have 99 BGP sessions with other routers. Right?
Mm-hmm.
So how we will deal with this situation?
So route reflector we are going to use.
Yes.
And full mesh is not always advisable to use, right?
Yeah. So basically, for example, if you have like, if we count that very low number of routers, if we have R1, R2, R3. So we have three routers. In that, it seems very okay. Like R1 will build neighborship with R2, R2 will build neighborship with R3.
Mm-hmm.
R2 will build neighborship with R2, and R3 will build neighborship with R. They will also build neighborship with each other. So they have a neighborship session. R1 is having a neighborship session with R3. So two sessions.
Mm-hmm.
R2 is having session with R1 and R3. Two BGP sessions is R2 having right now. R3 is also having two BGP sessions. The total number of BGP sessions is 6 here, right?
Mm.
And if we count it as one, for example, like if we see R1 and R2 is having only one session, right? If we count it from R1 side or if we count it from R2 side? Yes or no?
Yes.
Like, see, R1 and R2 is sharing a common session, right?
Mm-hmm.
If you count it from R1 and if you count it from R2, we'll count it as 2, but still there is only one session between R1 and R3. So we can divide the total number by 2, right?
Okay.
Let me make clear to you. See, we have total 3 routers, right?
Mm.
R1 is having session with R2, R2 is having session with R1, but at the end of the day, they are sharing a common session, right?
Mm-hmm.
We are not going to count it as two sessions between R1 and R2. There are only one session between R1 and R2, right?
Right.
We'll divide the total number by 2. So we'll calculate like n minus 1 upon. Is it clear?
Okay.
Let me repeat it again.
Yeah.
See, this is R1, this is R2, and this is R3.
Mm.
Going to configure full mesh iBGP. You are going to configure session between R1 and R2, right?
Yes.
R1 and R2 and R2 to R1. Session is same, right?
Uh-huh.
Between R2 and R3, between R1 and R3. This is what? This is full mesh iBGP. So how many total sessions are there? 3 BGP.
Okay. Yes.
Right.
Mm-hmm.
For example, if you have 100 routers, so each router will have 99 BGP sessions. But the total number of sessions is 100 upon 100 minus 1 upon 2.
2. Okay.
50. 50 multiplied with 99. So calculator,
Mm.
50 multiplied with 99 is equal to 4950.
Mm-hmm.
So see, if you have 100 routers inside an AS, and if you are going to configure full mesh iBGP, so you will end up having total number of sessions equal to 4950 sessions, 4950 sessions.
Mm-hmm.
Okay. All right, Heather.
Yeah.
And because of this, There's a graph. Can you see this?
Mm-hmm.
On one side, we have number of iBGP speaking routers, and on this side, we have total number of iBGP sessions. So if number of iBGP speaking routers will increase, as a result, number of iBGP sessions will also increase. All right.
Mm-hmm.
If you see, if you have 100 routers, in that case, you will have around 4950 BGP sessions if you'll configure full mesh iBGP. All right.
Mm.
You'll configure full mesh iBGP. Okay. In iBGP full mesh, we have scalability issues. Now let's discuss about the next, which is route reflector. Okay. If you have any doubt in full mesh iBGP, please feel free to ask Heather.
No, that's fine.
Okay. So now route reflector. This is also known as R. All right.
Mm-hmm.
So the meaning of this thing is in its name, like as its name suggests, route reflector. It is like kind of a mirror. You stand in front of a mirror, the mirror will reflect your picture as it is. So what mirror is doing here, mirror is creating a reflection. Likewise, RR will also create a reflection of the prefix. How? So basically, if we talk about a simple topology, R1, R2, R3. We have three routers here connected with each other. This is R1, so router 1, router 2, and router 3. 12.1.1.1/24, 12.1.1.2/24, 23.1.1.1/24, 23.1.1.2/24. This is the topology. All right, Heather? Normally what we do, we configure full mesh iBGP, but this time I'm not configuring full mesh iBGP. So I'll configure the router BGP 100, neighbor 12.1.1.2, remote AS 100. So you know that this is what? This is iBGP neighborship, because the local AS and remote AS is same, right? Then I'll go to R2. I'll configure that neighbor is 12.1. Neighbor is 23.2, remote AS is 100. And then I'll go to router 3. I'll say 23.1.1.1. Can you call it full mesh iBGP?
Kind of, yes.
No.
Except for the router 2 is removed, so they will break.
No. This is not called full mesh iBGP. Rather, full mesh iBGP means each router is having a BGP sessions with every other router. So if you see,
Okay.
R1 is not having any BGP session with R3. And vice versa is also
right.
You can't call it full mesh iBGP. All right.
Yeah.
This is partially matched topology. So now, if we have a neighbor here on this side, this is, for example, router 4, and router 4 is connected with R1. So here I am having 11.1.1.1, 11.1.1.2/24. This is the configuration. So if I'll go to router 11, I'll say neighbor on router 11, I'll say your neighbor is router BGP 200, neighbor is 11.1.1.2, remote AS is 100. Okay, then? And on R2, sorry, on R1, I'll configure neighbor IP also. Like I'll say neighbor 11.1.1.1, remote AS is 200. So this is an eBGP session, right? This is an eBGP session. So if R4 or this router is advertising a prefix to R1, R4 is advertising a prefix to R1, which is X prefix, and it is adding its own AS number in the AS path list, right? So router 1 has received a prefix from an eBGP neighbor. Can R1 advertise this prefix to R2? Heather, is it possible? Yes, because prefix is received from. If a prefix is received from eBGP neighbor, it can be advertised to iBGP neighbor, right?
Right.
R1 will advertise this prefix to R2, but it will not add its own AS number because this time it is advertising it to a iBGP neighbor. Now R2 is receiving this prefix from iBGP. Then R2 will not advertise this prefix to R3, right? That's the problem. If you'll not configure full mesh iBGP, R3s will not get this prefix.
Yep.
R3 will not get this prefix.
Fixes.
So what can be done here? Here we have to configure route reflector, right? Because we are not configuring full mesh iBGP this time. So if you are not configuring full mesh iBGP, you have to configure route reflector, right? Now let's talk about that. What is route reflector and how it works? So the route reflector is a very interesting thing here. In route reflector, as we've already discussed, that we have three roles here. First is known as RR, then client, and then non-client. All right. RR, client, and non-client. So we go to VMware and starting evng so that I can show you it like practically. Okay.
Okay.
Now you will say that, okay, how we can decide the roles, how we can decide that who is going to be RR, who is going to be client, and who is going to be non-client. How we will make the config. Okay.
Okay.
The configuration is you don't have to like make any complex configuration. You just have to go to router 2. If you'll say neighbor 12.1.1.2 is client. Okay. If you run this command, what R1 will become? R1 will become RR and R2 will become client. All right. R2 will become
Client.
Or if you go to R2, for example, and if you go to R2 and on R2, if you configure something like this, neighbor 12.1.1.1 client. In this case, what R2 will become? R. And what R1 will become?
Client. Okay.
No, what about R3? For R2, what R3 is? All right, if you haven't given the client command, it means R3 is going to be non-client.
Okay.
R3 is going to be a
non-client.
Now, what is the rule? Rule is very simple. So we have mainly multiple rules here. We have three roles, right? Or you can say three groups. First is route reflectors. Second is route reflector clients, also known as client or client peers. And then tabular iBGP speakers, also known as non-client. Okay. So the rule is here. First rule is an RR advertise or reflect on leads
Best.
best path. So what does it mean? It means if R2, sorry, R3, R2, yes. So R5. This is the topology, and R5 is also running AS100. All right,
Mhm.
and R5 is also configured as client. So now R2 is having two clients. The X prefix will come via this path also, and X prefix will come via R1 also, right? So first R2 will decide its own best. R2 will decide its own best path, and only best path will be advertised to clients or next routers. Okay. So an RR is always going to advertise the best path. Rule number 2. An RR always advertise to eBGP peers. This is a very simple concept. See, like that. If R2 is an RR and R2 is connected with, for example, router 6. Okay.
Mhm.
And between R2 and R6, the neighborship is
EV.
no matter how R2 is receiving a prefix. Is it receiving from a client? Is it receiving from a non-client? Or it is receiving from an other route reflector? It is always going to advertise that prefix to eBGP neighbor. Okay.
Mhm.
It is always going to advertise that prefix to
EV.
eBGP neighbor. So mainly the rule is here. An RR client follows the regular iBGP loop prevention rule when advertising prefixes. Additional rule must be followed if advertising. So it is making it complex. Let me make it very simple for you. So if you have this one like R1, R2 and R3, all right,
Mhm.
you configured R2 as RR. And if you have configured it as client, and if you have configured it as client, okay. So if R1 will give a prefix to R2, R2 will give this prefix to next R3, okay.
Mhm.
iBGP is running here, but iBGP is making it flexible now. We don't have that strict rule that a prefix received from an iBGP neighbor cannot be advertised to next iBGP neighbor, right? We are not following that
Yeah.
rule anymore. So when R2 will receive a prefix from a client, it can advertise that same prefix to next
R.
client. Okay? So rule number 1 here, prefix received from a client can be advertised to next client via the route. All right.
Mhm.
This is the first rule. Second rule. If you have this topology, and for example, this time R3 is a known client. Okay. Rule number 2. Prefix received from a client router can be advertised to next non-client, and vice versa is also. Okay, other.
Mhm.
I will say that how we are going to configure non-client. See, by default, each and every router is a non-client. Okay. Don't have to configure anything for non-client. You have to make the configuration only for client routers. All right.
Mm.
The third rule is this is what non-client, and this is also a non-client. Okay. It will be clear to you when you make the configuration. I think, and I can see right now you're a bit confused, but don't worry. A prefix received from a next non-client routers. Okay.
Mm.
So if R1 will give a prefix to R2, and R2 is acting as route reflector this time. So R2 is not going to advertise this prefix to R3. All right.
Mhm.
Yes. So let me take you to Eve and G. Let me show you that how it works, and then we'll discuss the additional things also. .34.1.1.0 is less than. I'm going to do here as a
Are you sharing the CLI command as well?
what?
Did you open the? Okay.
Can you see again, Heather? Hello.
Yeah. Not now.
What you said?
I cannot see the putty. I can only see the routers.
Yeah, I haven't opened putty yet. Don't worry.
Okay. Okay. All right.
Between R1 and R2, I'm going to configure iBGP. Between R2 and R3, I'm going to configure iBGP, and between R3 and R4, I'm going to configure iBGP. All right.
Okay.
So we don't have full mesh iBGP here. All right.
Mm-hmm.
What I'll do now, I will advertise a prefix from R1. R1 will give this prefix to iBGP neighbor, but R2 will not give this prefix to R3, or R3 will not give this prefix to R4. So what is our practical today? We have to make sure that this prefix is present on R4 without configuring full mass iBGP.
iBGP.
Let's see how we can achieve this. So I'll open Putty now and I'll set the screen. R1, R2, R3, R4. Can you see it now?
Yes.
See, show IP interface brief, exclude, understand. IP address is already configured here. Okay.
Mm-hmm.
And if I show you on R2, show IP interface brief, exclude, understand. You can see R2 is already having the IP address. Then R3. Show IP interface brief, exclude, understand. And likewise R4. Show IP interface brief, exclude, understand. Right?
Mm-hmm.
So between R4 and R3 are using 34's network. Now if I'll go to R1 and I'll configure the BGP neighborship. So router BGP 100 neighbor. Remote is 100. All right.
Mm.
R2 router BGP 100 neighbor. Remote AS 100 and neighbor is 23.1.1.2. Remote AS is 100. Okay.
Mm.
Go to R3 configuration mode router BGP 100 neighbor. 23.1.1.1 remote AS 100 neighbor. 34.1.1.2 remote AS 100. R4 router BGP 100 neighbor. 34.1.1.1 and remote AS is 100. Okay.
Okay.
So IP BGP is something. You can see that R4 is having neighborship with R3, right? Now let's go to R1 and advertise the loopback in BGP route BGP 100 net and 1.1.0 mask. Okay.
Mm-hmm.
So IP BGP. Now if I'll go to R2, show IP BGP. Can you see the prefix in BGP table? Yes, right.
Mm.
What is the meaning of this I on the left side?
Internal.
Internal
iBGP.
iBGP neighbor. And what is mean? This I on right side?
It's the iBGP.
It's an origin code, not iBGP. Okay.
Okay.
This is an iBGP on the left side, and this I means origin code.
Okay.
But when you go to R3, show iBGP. Can you see the prefix here?
Nothing.
Why?
Because it's not advertising or injecting in the routing table.
Yes, because the prefix received from an iBGP neighbor cannot be advertised next iBGP. Okay.
Mm-hmm.
So now we have to configure, but we have to configure route reflector this time. Okay.
Okay.
So what I'm going to do here, I'm going on R2. And before that, let me start the capture. E0/1. The link between R2 and R1. So we have captured the link. Okay. Now I'll go to R3 and see router BGP 100 neighbor. And yes, route reflector client. All right.
Mm-hmm.
So if we'll configure, this one as RR client, so R2 will automatically become RR for R1. Okay.
Okay.
And what R3 will become for R2 right now?
Non-client.
If you not configure it, and if you run this command, then R3 will also become client. Okay.
Okay.
Let's not configure that. So first of all, I've configured R1 as route reflector client. So you can see that the BGP session is re-established, right? BGP session is re-established.
Re-established.
So we can see the update message again between R1 and R2, and R1 and R2 and R2 to R2. So if you open this update message, roll out and then R1 and R2. Okay. Yeah. So now if I go to R2, CCIE BGP, you can see the prefix here, right?
Mm-hmm.
Look, received from
RR client.
RR client. And if I open the details, show IP BGP neighbor details. In show IP BGP neighbors, you can see that BGP 12.1.1.1 is here. BGP state is established.
Established.
And So here you can see that there is no changes in this mass and this out. We can't see anything here, but we can see it in the BGP table, right? CIP BGP. This is a summarized table, CIP BGP detail. So you can see that this prefix is received from a RR client. I'll go to R3, and if I run the command this time, can you see the prefix?
Okay.
This time the prefix is present in the BGP table of R3,
R3.
right? And if I say CIP BGP detail, you can see right now this path is inaccessible. This prefix is inaccessible.
Accessible.
Why? Why this?
It's not directly connected. Yeah.
No, it's not directly connected. It's not about the directly connected. The issue is Route Reflector is not updating word next door. All right. So if you remember, there was a rule
Through the self.
When iBGP, it is not going to update the next host address, right? So in this scenario, R3 does not know that how to raise 12.1.1.1. That's why R3 is not treating this prefix as best. All right. What you can do here, you can go to R2. Router BGP 100. Let me try neighbor 23.1.1.1 next option. Okay. Clear IP BGP star out. Can you see any changes here? Hello?
No. No.
So let me tell you a rule about Route Reflector. And the rule is very, very simple. So basically, RR is never going to update next hop prefix to client or a non-client. Okay. Why? You'll say why. So because if you have a topology like this, R1, R2, R3, and R4. R1 is also connected with R4, all right? Okay, Adab? What you have did, you have configured neighborship between R1 and R2, R1 and R3, R2 with R4 and R3 with R4, okay? So for example, if R1 is having a prefix X, for example, R1 will give this prefix to R2. R2 is not going to advertise this prefix to R4 because of iBGP rule. So what I did, I've configured R2 as RR. All right. So if R1 will give this prefix to R2, R2 will give this prefix to R4, right? If R2 will advertise, or if R2 will update the next hop, if R2 will update the next hop, if it will start advertising itself as the next hop, all the traffic from every other router will pass through RR. Yes or no?
Yes.
So RR will also become the central point for the data traffic. But we haven't designed RR for this. We have designed RR just to share the routing information, not for the actual traffic. Yes or no?
Yes.
Whenever R will relay any prefix received from a non-client prefix or client prefix, if it will update the next hop, it means every other router will pass through the RR.
Mm-hmm.
And okay, that's not a big deal. But if a router is already having a smallest path to reach the other router, but it will still go via RR in that scenario. That's why RR is never going to update the next hop address while advertising prefix to a client or a non-client router. All right.
Mm-hmm.
So you have executed this command on R2, but this is not going to make any effect. You can still see that next hop is still 12.1.1.1. Okay.
Mm-hmm.
So what you have to do here? Any idea, Heather?
No.
So what you have to do here, you have to configure IGP. Okay.
Okay.
As we have configured when we were configuring full mesh iBGP, right? So in that case, we were using IGP for the reachability from one router to another router. We have to do the same thing here. We have to configure IGP for reachability. So let's go to R1 and enable OSPF. But please make sure that you don't advertise 10.1.1.0 in OSPF. Router OSPF1, IP OSPF1 area 0. Go to R2. Interface range E0/0, E0/1. IP OSPF2 area 0. R3. Interface range E0/0, E0/1, IP OSPF3 area 0. Let's go to R4. Interface gigabit 0/0, IP OSPF4 area 0. So IP OSPF neighbor. Neighborship is up, right, Adam?
Yes.
So if I go to R2, show IP BGP, and now if we go to R3, you will see that show IP BGP. Now this prefix is best, right? Because they know that how to reach 12.1.1.1. Show IP BGP detail. Can you see this?
Not advertised to any peer. Yep.
Why? Because this is a client, this is RR, this is non-client. This is what? If nothing is configured, it means they are no client. If non-client is receiving a prefix to from RR, it cannot advertise that prefix to next non-client. So what you can do here, in this scenario, this is client and this is RR. This is non-client, right? But you can configure R3 as RR also. This will become client for R3, and see, for this RR, this is non-client and this is client. For this RR, R2 is what? Non-client.
Non-client.
R4 is what? Client, right? This time R3 will be receiving a prefix from RR, which can advertise to next client. So let's see what we can do here. I'll go to R3 and I'll say router BGP 100 neighbor 34.1.1.1 route reflector line. All right. Now if you go to R4, you will see show IP BGP. And show IP BGP details. This prefix is received from RR. So you can see we are not going to advertise this prefix to any peer because we don't have any neighbor yet. Okay.
Okay.
In a topology, you can have more than one RR, and there is no such command to configure RR. Our router will become an RR whenever you go to a router and you configure any of the neighbor as client. So that router will automatically become
RR.
So if we go to R3, see show IP BGP neighbor. So show IP BGP details. Advertise to update group, which to we'll talk about it, what it is. We'll talk about cluster list as well. Okay. And if we go to R1, sorry, not R1, R2. Show IP BGP detail. We have received this prefix from a RR client, right? Because we are receiving this prefix from R1. So for R2, what is R1? R1 is a RR client. Yes or no?
Yes.
Now I'll go to R4 and I'll create a loopback on R4 as well. Interface loopback 1 IP address is 40.1.1.1/24. Router BGP 100 network 40.1.1.0 and mask 255.255.255.0. Okay. If we go to R3, you can see now show IP BGP. R3 is receiving a prefix 40.1.1.0 from R4, right? Show IP BGP detail. You can see 40.1.1.0 prefix is received from a
RR client.
Now if I'll go to R2, you can see the prefix 40.1.1.0, right? Show IP BGP detail. All right.
Yep.
This is received. So if a router is receiving a prefix from a RR client, you will see it clearly here, received from a RR client. If you see this, if 40 is prefix, is there any such output that this prefix is received from a RR client? No, right? It means this prefix is received from a known client, right? If I remove the command for an instance, rule show run pipe section router BGP. Router BGP for an instance, I remove this command. When you go to R1, you will see show IP BGP. R2 is receiving prefix 40.1.1.0/24, right?
Mm-hmm.
But R2 is not advertising that prefix to R1 because show run pipe section router BGP. R2 is receiving that prefix from R3. And what is R3? R3 is non-client for R2. Yes or no?
Yes.
And R1 is also a non-client for
Non-client.
R2. So R2 is not advertising a prefix from a non-client to a next non-client. So likewise, you will see that show IP BGP. R2 is receiving this prefix from R1, but not advertising to R3, right?
Mm.
If you haven't configured any command, it means every router is a non-client, right? And the same iBGP rule will apply here. A prefix received from an iBGP neighbor cannot be advertised to next iBGP neighbor. But what I'm going to do here, I'll go to R2 and I'll make the configuration again. I'll say router BGP 100 and 12.1.1.1 is going to become RR client again. Okay.
Okay.
So IP BGP. You can see now 10.1.1.0 is here. So IP BGP detail. It will show you that we are receiving this prefix from a RR client. Now if we go to R3, we'll receive this prefix and R3 will advertise this prefix to R4, right?
Okay. Yep.
Because on R3 I have configured R4 as client. So for this router, this is a client and this is a non-client, right?
Non-client.
But then R3 is a RR4, R4 and R
R4.
client. So if you haven't executed any command, it means R2 is what for R3? R2 is for R3 is a non-client, right?
Mm-hmm.
So R4 is advertising a prefix 40.1.1.0/24 to R3. R3 is receiving from a client and it can advertise it to next non-client. Or maybe it can be an RR here. So both of the routers are acting as RR, right?
Mm-hmm.
You can see it is RR as well. So you will see that between RR, you must have full mesh iBGP. Okay.
Mm.
And then RR will advertise this prefix to client. So you can see here the total number of BGP sessions are very less because we have only one session between R2 and R3, between R2 and R2 and 3, and between R3 and R4 we have only one session. So we have how many sessions here?
3.
3 BGP sessions, right?
Mm-hmm.
In comparison of full mesh iBGP. If you configure full mesh iBGP here, you have to configure a BGP session between R1 and R2. 1. You have to configure BGP session between R2 and R3. 2. You have to configure BGP session between R3 and R4.
4.
Then you configure BGP session between R1 and
R4.
4, right? Then you have to configure one BGP session between R2 and R4. 5. And you have to configure one BGP session between R1 and
R3 and R1.
5, 6, I think. So we have total, if we have, you can say 4 routers, so we have N minus 1 N upon 2 in case of full mesh iBGP. So if you have 4 routers, you'll see you'll have total 6 BGP sessions, right?
Mm-hmm.
We'll have total 6 BGP sessions if you have 4 routers. But right now we have only 3 BGP sessions
3,
between R1 and R2, between R2 and R3, and between R3 and R4.
4.
This is the benefit of building using Route Reflector. Okay.
Okay.
There are certain rules in Route Reflector. Now you'll say, okay, what about the routing loops, right?
Yes.
Because as we have learned in the last few classes that a prefix received from an iBGP neighbor cannot be advertised to next iBGP neighbor in order to prevent routing loops, right?
Mm-hmm.
But right now what we are doing, a prefix received from an iBGP neighbor is advertised to next iBGP neighbor, right?
Mm.
What can happen here? This can cause a routing loop. This can cause a routing
Loop.
loop. But yes, if we have this, you can say this design, we must have a way to prevent routing loops as well, right?
Mm-hmm.
We have something known as cluster list. Talk about it right now. Okay.
Okay.
What is cluster list? So, okay, just give me 5 minutes, Yadav. All right,
Okay.
I will be back. Hello.
Okay.
Yeah. So now let's see what we have in the book. If you see this topology, can you see this diagram?
Mm-hmm.
R8 is having an iBGP neighborship with R5. R5 is configured as RR, right?
Mm.
So you know that configured router as RR, you don't have to make any separate configuration. What you have to do for there, you just have to go to the router BGP, whatever the AS number you are running, then you have to say, for example, neighbor R6, then route reflector client. Okay.
Mm.
Then you'll say neighbor R7. Route reflector client and exit. Right.
Mm.
So now if we haven't configured M2 between R3 and R4, so it means R3 and R4 are simple iBGP neighbors, right? So if they are simple iBGP neighbor, it means they are acting as non-client. Okay.
Mm.
R3 and R4 are acting as non-client.
Non-client. Okay.
Yeah. Now, when R5 will receive this prefix from 172.16.0.0, R5 is going to advertise this prefix to all the other routers, right?
Mm.
This is not something new, as we know that if a prefix is received from iBGP neighbor, RR is going to advertise that prefix to next iBGP neighbors, right?
Yeah.
But if you have a AS here, for example, if you have AS here, AS 100, R3 will receive a prefix. Normally between R3 and R5, what kind of neighborship is this? iBGP, right?
iBGP.
But we are using route reflector here this time. So if non-client will advertise this prefix to RR, RR can advertise this prefix to client. But when R5 will receive a prefix from R3, R5 is not going to advertise that same prefix to non-client. You know that prefix received from a non-client cannot be advertised to next non-client, right?
Mm-hmm.
So if we see next, if an RR learns a prefix from an external peer, it advertises to all its client and non-client, right?
Mm.
Rule number 6. If the prefix comes to an RR through a non-client iBGP peer, if the prefix comes to an RR through a non-client iBGP peer, the RR reflect route to all its clients. All right.
Mm-hmm.
And rule number 6, it is talking about the scenario which we have drawn here right now. So basically, what it is saying that if RR is receiving a prefix from non-client, because R3 is what? R3 is a non-client router, right?
Mm.
If an RR is receiving a prefix from a non-client, if the prefix comes to an RR through a non-client iBGP peer, the RR reflects the route to all its clients. So R5 will advertise this prefix to R6 and R7 only, but R5 will not advertise this prefix to R4, right?
Right.
Then rule number 7. If a prefix comes to an RR from a client, if an RR receives a prefix from a client, the RR reflects the route to all other clients and non-clients. For example, if R6 is giving a prefix to R5, so what is R5 here? RR. In that case, RR is going to advertise this prefix to non-clients and clients both. All right.
Mm.
Now read this note.
If all clients are in the same peer group, an RR reflects the prefix received from a client to all client, including the client that sources the prefix. Route reflection and peer groups are discussed later in this chapter.
All right. Now, what is cluster?
Cluster is a high availability, so
So basically, if you go to the BGP table, if you have show IP BGP detail, if you see in this prefix 40.1.1.0/24, can you see the cluster list? Plus, you can see 23.1.1.1 and 34.1.1.1. Right?
yes.
23.1.1.1 and 34.1.1.1. So what is a cluster normally? If we talk about only about a cluster, so this is R1, this is R2, this is R3, this is R4, this is R5, this is R6. So in this topology, for example, R3 is configured as RR and every other router is configured as client. Okay.
Okay.
Router is configured as client. So this is known as a cluster. Okay.
Hmm.
But the problem with this cluster is that if R3 will goes down, right?
Hmm.
In this topology, if R3 is not available, or for example, if R3 is out of operation, so you know that all other routers won't be able to exchange routing information, right?
Hmm.
All other routers won't be able to exchange routing information. So what we need sometimes, we need redundant RR. So we hear and we see it. Clustering is introduced to provide redundancy in an RR environment. In a traditional clustering design, multiple RR are used to serve one or more clients, right? Hello.
Hmm.
In a traditional clustering design, multiple RR are used to serve one or more clients. These RR are configured with an identical cluster ID, which is a 4-byte BGP attribute that commonly takes the form of an IP address and defaults to the BGP router ID. If two routers share the same cluster ID, they belong to the same cluster. An advertisement that bears the same cluster ID is ignored by the receiving RR in the same cluster. So basically, what it is trying to convey here, okay, let me explain it here. So this is R1, this is R2, this is R3, this is R4, this is R5, and this is R6. Okay,
Hmm.
so in this topology, each router is having a BGP session with R3. I'm configuring R3 as RR. So each router is having a BGP session with R3. All right.
Hmm.
They're not having BGP session with each other. So now all the routers are acting as client. So now what R1 will do, whenever we will configure a router as RR, if we go to R2, because R2 is configured as RR, right? So IP protocol. So IP protocol. So IP protocol. We can say show IP. Show IP. Let's try this. See here, global cluster ID is 23.1.1. Right, and configured
Hmm.
is 0.0.0.0. So basically the cluster ID, this cluster ID is used to prevent routing loops inside a cluster. Okay,
Hmm.
this cluster ID is used to prevent routing loops inside a cluster. So basically, whenever you configure a router as cluster, by default, that router will use its own router ID as cluster ID, right?
Mm-hmm.
So, for example, if we have a topology like this, and R4 is also configured as R. So router ID of R1 is 3.3.3. Router ID of R4 is 4.4.4. Okay,
Mm.
R2 is having neighborship with R4. R1 is having neighborship with R. R5 is having neighborship with R4. R6 is also having neighborship with R4. So all of the clients are advertising this prefix to R4. For example, R1 is advertising X to R4. R1 is advertising X prefix to R3 also. Right?
Mm.
You know what R3 will do? R3 will add cluster ID with this prefix. R4 will also advertise, sorry, cluster ID with this prefix. All right. But they will add cluster ID. When R3 will advertise this prefix to R5, R5 will receive a cluster ID 3.3.3.3 with X prefix. R5 also receive a cluster ID 4.4.4.4. Right?
Mm-hmm.
Then R3 will also advertise this prefix to R4, X 3.3.3.3. Now, R4 is already having the prefix. R4 is already having the prefix, and R4 will
Prefixes.
advertise that prefix to R3. Right?
Mm.
So what they are doing? They're creating a loop. Prefix received from a client advertised to RR. RR is also advertising the same prefix to another RR. Because right now they're using different cluster IDs. So what you can do here, whenever you are using multiple RR, right?
Mm-hmm.
Whenever you are configuring multiple RR, you will go to each
RR.
router and you will configure the same cluster ID. You will configure the same cluster.
Cluster ID.
So when R3 will advertise this prefix to R4, R4 is not going to receive that prefix because same cluster ID is present in the prefix. Okay.
Mm-hmm.
So now if we see here that these RR are configured with an identical cluster ID. So but not by default, all right. By default, they are going to decide their own router ID as a cluster ID, which is a 4-byte BGP attribute that commonly takes the form of an IP address and default to the BGP router ID. Defaults to the BGP router.
Router ID.
By default, the router ID is used as cluster ID. But by default, if you have two routers, the two routers are already having different router ID, right?
Mm-hmm.
So they will end up having different cluster IDs. They will end up having different cluster IDs.
Cluster ID.
Yes. So what you will do in that is you will go both of the RR and you will configure a cluster ID manually. For example, if I go to R2 router BCP 100 TCP cluster ID. All right. We'll configure a cluster ID manually here. But not in this topology. This is a linear topology. Okay. But not in this topology. For example, if I configure cluster ID as 2.2.2, and if I go to R3 as well, router BGP 100 BGP cluster ID as 2.2.2. All right. And if I say debug IP BGP, let me take you to R1 and I create a local IP address 10.1.2.1 router BGP 100 network 10.1.2.0 mask. R2 will advertise this prefix, sorry, R1 will advertise this prefix to R2, so IP BGP, so IP BGP detail. You can see right now. Prefix received from an RR client, right? Received from an RR client. But when we'll go to R3, so IP BGP. Can you see both of the prefixes? Can you see the prefix?
So 40.1.1, yeah.
We can't see 10.1.1.0 or 10.1.2.0. Yes or no?
Yes.
Why? Because on both we have configured same cluster ID.
Right.
So if I say capture the link between R2 and R3, which is E0/0, and if I go to R1 again, interface or router BGP 100, interface loop at 3 IP address 10.1.3.1, router BGP 100 network 3.0 mask. Now, if you'll see in the update message, you'll see that R2 is giving an update to R3. Can you see this message, Heather? 23.1.1.2 is, sorry, 1 is giving an update message to 23.1.1.2. It means R2 is giving an update to R3, right? If you go to the update message and if you see the path attribute, in the path attribute, you can see what? Cluster list. What is the cluster list? 2.2.2.2. This is the cluster ID, right? When R Then R2 will advertise the same prefix to R3, but R3 is having cluster ID similar to R1. So IP BGP cluster ID. What is the cluster ID? 2.2.2. And okay, debug IP BGP update. You can also see the error message here, debug IP BGP update. If I go to R1 for an instance, if I say loopback 1 shutdown, and if I say no shutdown, but prefix will be removed and then prefix will be advertised again, right? You can see what? You can see here that 23.1.1 are in same class reflected update about 23.1 receive update about 10.1.1.0 denied reflected from the same cluster, right? because this is not the proper design, because this is a linear topology. This is a
Right. Linear.
topology. But we can use this concept in this topology, R3 and R4, right? We can use the same cluster ID on both the RR.
Okay.
Because otherwise what will happen? R1 will give this prefix to R3, R3 will give to R4, R4 will give it back to R1. Right? But if we'll use the cluster thing here, when R3 will give this prefix to R4, R4 is not going to receive it from R3 because both of the routers will be sharing a same
Cluster ID.
cluster ID. Right? So I'll do the audit cluster ID from the book. And then we'll discuss about next things in BGP. We'll also talk about what is originator ID, but not today, okay? In the next class.
Okay.
That's all for today, Radha.